I really like apples. I like apples so much that I have 3 apple trees in my backyard, and this year I got 6 apples on each tree for a total of 18 apples. That was really exciting. But there's someone who likes apples even more than me, and that's the squirrel that lives out back there. And that squirrel seemed to take about 2 apples every week, and then by the end of the summer, I had no more apples left. So this squirrel took 2 apples every week. I had no apples left. I wonder how many weeks it took for the squirrel to get all of the apples. We can figure this out algebraically. So let's write an equation for it. What's the unknown? Well, we're trying to figure out how many weeks it took for the squirrel to get all of the apples. So we'll define a variable, x equals the number of weeks. We could be a little bit more specific and say the number of weeks until the squirrel took all the apples, but number of weeks is good enough. And now we can write an equation. Before we write an equation, writing up a verbal model can be pretty useful so we can see what the equation will look like. So I'm beginning with this starting number of apples. What happened to my starting number of apples? Well, the squirrel took apples, so I lost 2 per week. After losing 2 per week, I was left with no apples. Well, that's interesting. Starting number of apples, lost 2 per week, and then left with no apples. All right, now we can write an equation. The starting number of apples, if you remember I said I had 18 apples, so I started with 18 apples. Lost. The mathematical operation for lost, subtraction. 2 per week. So for each of these x weeks I'm losing 2 apples. So 2 times the number of weeks is how many apples I'm losing. So I end up with minus 2x. Left with, I will be equaling no apples. No apples is 0 apples. 18 minus 2x equals 0. That is our algebraic equation for this situation. To solve this equation, we need to look at undoing the operations that are happening in the equation. Right here, x is being multiplied by 2. That result is being subtracted from 18. And we're starting with 18. Let's work backwards. I've got to get rid of the 18 from the left side of the equation. Get rid of the constants, so we can have the constants on one side of the equation and the variable on the other. To get rid of the 18, I will subtract 18 over here. In order to maintain equality for the equation, I must subtract 18 on the other side as well. 18 minus 18 is 0, so the 18 and negative 18 will cancel out. And that leaves us with, be careful here, this negative stays with the 2x. This is negative 2 times x when we consider it as a term by itself once the 18 is gone. Negative 2x equals negative 18 is the resulting equation. The next step, to get x by itself, right here x is being multiplied by negative 2. The inverse operation of multiplying by negative 2? Dividing by negative 2. So I divide both of these sides by negative 2. Interestingly, even though I have negatives in this equation, those negatives will go away and I'll end up with a positive result because I do need to have a positive number of weeks, otherwise this problem isn't going to make any sense. Negative 2x divided by negative 2. The whole point of dividing by negative 2 was to isolate the variable and give me x. On the right side of the equation, negative 18 divided by negative 2, and negative divided by negative, positive. X equals 9. With x equals 9, we now know the number of weeks and we can answer the actual question. So, in 9 weeks, the squirrel took all of the apples. Well, next year I'll try to keep those apples away from the squirrel.